chapter 20 physics, theory video 4. So we are dealing with the ideal gas equation. So in O levels we have already met the equation PV equals nRT, and here we are going to deal with another equation which is PV equals nKT. So this actually combines all the variables that we have discussed when it with regards to the pressure that is created in a gas. So in PV equals nRT, you can remember that R is the gas constant, simple N is the number of moles, and PVT you know what they are. In PV equals capital NKT, capital N stands for the number of molecules, and K is the Boltzmann constant, which we will be learning at a later stage. This equation is called the equation of state for an ideal gas. So you must remember what an ideal gas is. We learned in the earlier videos what it is. So then this R, the proportionality, the universal molar gas constant. The universal molar gas constant has an experimental value of 8.31 joules per mole per Kelvin. So what we need to understand is if any gas, whether it is light like hydrogen or very heavy like carbon dioxide, whatever it is, without that affecting, without the weight of the gas affecting, if it is behaving like an ideal gas, we use the same constant R. Right, the molar gas constant is going to be the same. So then the equation PV equals nRT or PV equals nKT, so these are known as equation of state. So that is something that you need to remember, and along with the experimental values, especially for R. So then we might have to combine these equations to find out different details when we do the calculations. So now we know the equation to find the number of moles, that is mass over molar mass. Then for example, if they ask for how many moles of oxygen is present in 1.6 kilograms of oxygen, you know that oxygen has a molar mass of 32 grams. How do we get that? Oxygen is a biatomic molecule, O2. Then one mole of oxygen atoms has a mass of 16 grams. So then O2 will have 32 grams per mole. Then 1600 is the mass in grams. So you divide 1600 by 32, then you get 50 moles. 50 moles is the number of moles that you have in it. Then we need to move on to other questions. You know, using this number of moles, we can figure out different other values. Right? Now let's look at this example here. Calculate the volume occupied by 1 mole of an ideal gas at room temperature 20 degrees Celsius and pressure 1.013 into 10 to the power 5 pascals. So we need to get the details properly. So here they have given us the room temperature they have given and pressure they have given. So we have to write down the details that they have given. P 1.013 into the power 5, N 1 mole of ideal gas. So N is 1, and they have given not capital N, simple N. So we have to use the appropriate equation. T they have given, so we have to take it in Kelvin, that is 293 Kelvin. Right, so that has to be done all the time because T, this is not theta, this is T. Then we substitute the values. PV equals nRT, because they are asking for the volume, then we make V the subject, then V equals nRT upon P, then we put the values and simplify that, we will get 0.0240 meter cube, right? That is, when you convert that into cubic decimeters, it is going to be 24, right? That is also something that you must remember. This conversion, 1 decimeter is 0.1 meters, right? That is 10 centimeters. Then 1 cubic decimeter is equal to 10 to the power minus 3 meter cube. So that conversion is also something that you must remember. So you already know that 1 mole of ideal gas would occupy 24 cubic decimeters. Now let's go to worked example 3. So they make it more and more complicated. So that is another factor you have to take into consideration. A tire contains 0.02 cubic meters of air at 27 degrees Celsius as a pressure of 3 into 10 to the power 5 pascals. So here they have given in cubic meters. First of all, we need to be very careful, because it's not in cubic decimeters that we use in the equation. It is in cubic meters. So remember that it should be taken accordingly, right? Then be very attentive about the units, because that is going to be a very important part in finding the correct final answer. So they might, to confuse you, they might give it in cubic decimeters, then you have to convert that into cubic meters. Then we use the equation of state PV equals nRT and find out the number of moles first. Remember, the temperature need to be in Kelvin. So we use those values, and then we will get 2.41 moles. Now here they are asking for the mass of the air in the tire. Then we use the equation of finding number of moles. We know the number of moles, right? Then mass equals number of moles into molar mass. Because they have given molar mass of air, we have to multiply mass equals number of moles into molar mass. Mass equals 2.41 into 28.8, that is going to be 69 grams. I hope you understood this. Please do question 7 to 12. If you have any doubts, please raise questions, then I will discuss them once again. Let's write a note on this. Ideal gas equation. PV equals nRT, comma PV equals nKT are referred to as equation of state. Remember, in PV equals nRT, n is simple. In PV equals nKT, n is capital. Then underneath that, define what they are. Simple n is equal to number of moles. Capital N is equal to number of molecules. Capital R is equal to universal molar gas constant. Within brackets, right, R equals 8.31 joules per mole per Kelvin. Then simple K equals Boltzmann constant. Then write down the mole equation, comma, underneath that, write now number of moles equals mass in grams divided by molar mass, gas per mole, also should be used for calculations also should be used for calculations. And I hope you understood. If you do not, please ask me questions.